check this out.
Okay,
I look good.
okay. On the street and I got my swag on. Okay, get the money, gotta get my bag on. Okay, triple.
Did you guys know? Every single day, the world consumes over 2.5 billion cups of coffee and unboxes millions and even tons of online delivery packages. But behind the modern convenience lies a massive environmental crisis. Traditional expanded polystyrene, or what we call as styrofoam, is petroleum-based, non-biodegradable, and will persist in our soil and oceans for hundreds and hundreds of years, with online shopping generating up to 4.8 times more packaging waste than traditional retail. Global plastic waste is on track to triple by 2060, with single-use packaging making up nearly 40% of that disaster. We cannot keep using 500 years plastic for 5-minute deliveries. The world doesn't just need another recyclable, it needs our solution, Ecoform. Instead of letting over 6 million tons of spent coffee grounds end up in landfills every year, we turn food waste and agricultural residue into protection. By recycling spent coffee waste, silica rice husk, and cassava starch, we synthesize Ecoform, a 100% bio-based, fully compostable, lightweight packaging alternative to styrofoam. By performing agricultural waste into a high-value packaging, Ecoform eliminates petroleum reliance, empowers a circular zero-waste economy, and proves that the future of packaging isn't plastic, it's biocomposite science. To turn this vision into a scientifically validated product, our project established 5 clear experimental objectives.
Next, let's look at the science and hands-on testing behind the Ecoform. Our biocomposite utilizes 3 parts synergetic formula. First, coffee whips creates a lightweight porous microstructure. Next, rice husk provide fibrous reinforcement for tensile strength and thermal insulation, and cassava starch acts as a natural biopolymer binder. To produce Ecoform, the agricultural waste materials including coffee grounds and rice husk will first wash, dry, and sieve to obtain a uniform particle size. Cassava starch was then mixed with water and heated to 90 degrees Celsius to initiate starch gelatinization, forming the biodegradable matrix. Coffee grounds and varying proportions of rice husk such as 5%, 15%, and 25% by weight were incorporated into the starch matrix to investigate their effects on the form's structural properties. The resulting composite mixture was molded and thermally processed to produce lightweight biodegradable form samples for subsequent performance testing.
The true power of Ecoform lies in its transformative environmental impact and circular design. By upcycling spent coffee grounds and rice husks, which these materials usually burned or dumped into landfills, Ecoform turns daily agricultural and food waste into high-value protective packaging. Unlike conventional styrofoam, which leaches toxic microplastics and persists for half a millennium, Ecoform completes a true zero-waste circular life cycle. When discarded, it returns directly to the soil, degrading naturally into organic biomass that enriches the earth without leaving behind harmful chemical residues. This creates an immediate win-win across the entire value chain. Coffee shops and rice mills transform costly waste disposal overseas into a new revenue stream. E-commerce giants and manufacturers lower their carbon footprint while easily meeting the strict international zero plastic regulations. Local communities enjoy cleaner soil, healthier ecosystems, and reduced landfill pollution. To rigorously prove Ecoform's real-world viability, we evaluated our prototypes across 3 critical empirical tests. First, the soil burial biodegradation test. After just 7 days buried in soil, our formulation showed visible decomposition. However, the 25% rice husk formulation achieved the highest mass loss, proving that higher natural fiber content accelerates microbial breakdown and speeds up organic decay. Second, the shock absorption test. When a 396 gram load was dropped from a height of 50 cm, 100% of our prototypes survived without cracking or structural failure. This demonstrates high kinetic energy absorption capable of protecting real-world cargo. This confirms that while Ecoform is fully compostable, its starch matrix maintains essential temporary structural integrity against ambient moisture. By comparing all parameters, our 25% rice husk formulation emerged as the clear, optimal performer. It provides the ultimate synergy, delivering maximum biodegradation velocity and robust shock absorption while maintaining practical moisture resistant for real-world shipping applications. Looking ahead, our big picture vision is to normalize Ecoform across global logistics infrastructure. Imagine a future driven by localized microprocessing hubs that convert regional organic waste directly into custom biopackaging, replacing petroleum plastics right at the source. As global packaging waste explodes to 2060, Ecoform won't just be an eco-friendly alternative. It will be the mandatory industry standard. By proving that high-performance packaging can originate from daily waste, Ecoform redefines how humanity produces, protects, and restores our The global packaging crisis cannot wait for incremental changes. We need immediate, scalable, biocomposite solutions. Ecoform proves that we can protect our products during transit without destroying our planet in the process. It is lightweight, durable, and fully compostable. This is Ecoform, from your morning cup of coffee to the future global packaging. Thank you and bye-bye!